Hi, it's Rob Bryanton, and this is my video blog entry for November 12th, 2007. Today's entry is called How to Make a Universe, and this is one that we're going to be playing that has as its background something you'll be able to find on YouTube if you type in Mandelbrot. Mandelbrot. This animation is called a Mandelbrot, the size of the known universe. This is a fractal math set, fractals being things that when you can zoom in on them, you keep finding more and more detail. There are a lot of things in nature that are this way as well. Coastlines is a common example, for instance, that when you look at the coastline, you can keep zooming in and go through bays and down into tiny little indentations along the coast and right down to deeper and deeper levels of magnification and keep seeing the same kinds of patterns repeating over and over. So if the animation that we're looking at right now, where we're starting from, we can imagine is the size of the known universe. We're going to keep zooming in and zooming in and zooming in. By the time it gets to the end, it takes about 3 minutes. You're at just the size of your computer screen, so it's a bit of a mind blower to watch, and hopefully it won't be too distracting to have this as my background today, but it does kind of fit in with the concept of what we're going to be reading, which is this blog entry called How to Make a Universe. So here it goes. We start with the unobserved quantum wave function. This is where, as quantum physicists say, information and reality are equivalent. Although quantum physics has no specific requirement for there to be 10 spatial dimensions in order for us to imagine this unobserved state, what we're talking about here is the multiverse, the timeless place where the potential for all possible and impossible universes exists. Where the potential for all possible and impossible universes exists simultaneously. Now we make our first observation. Quantum computing expert Seth Lloyd, in his book Programming the Universe, suggests that we can think of the Big Bang as the very first yes-no. And that's what we're thinking about here. Out of all potential expressions of reality contained within the timeless multiverse, we place the very first point which begins the creation of a universe. Physicists tell us that the only force that exists across all dimensions is gravity. So one of the things that we are likely to have already done with that very first yes-no point of entry is to choose a value, or at least a range of values, for what gravity is going to be in the universe we are planning to make. Let's call that first point the beginning of time. With our first point, we are narrowing down what the force of gravity can be for the universe we want to create. But before we can define a second point, we need to choose a value for the speed of light. No matter what dimension we're thinking about or how many dimensions we're imagining, time is the way that we change from one state to the next. But time is not a continuous line, it's actually a series of points, one after the other. For our own universe, those points are each one Planck length away from the next. So much the same as a movie is made up of frames that are being shown at a certain number of frames per second, we know that our universe is also being observed at a certain number of frames per second, and in quantum physics, those frames are called quanta. The length of time between those frames is entwined with the specific speed of light for our universe. And the idea that our universe is being created one frame at a time at the speed of light gives us a way to explain why it's impossible to exceed the speed of light within our universe. This also explains why it's impossible to observe anything smaller than the Planck length, which is about 1.6 times 10 to the minus 35 meters. Attempting to do so puts us back to where we started, between those frames of time, and back into indeterminacy in the timeless multiverse. Back in 1919, Kaluza sent a startling proof to Einstein, stating that the field equations for gravity and light can be resolved if they're calculated in the fifth dimension. Einstein ruminated on this idea for 2 years, then gave it his full endorsement. Here's what this tells us about our own universe then. It is being defined at the fifth dimension by the specific values it has for the strength of gravity and the speed of light. What if we wanted to create some other universe that had a different value for gravity and the speed of light? We would back all the way out to the indeterminate quantum field, choose a different point of entry, and choose a different frame rate for some other universe to be observed. We could even try making a universe that had gradually changing or oscillating values for gravity and the speed of light, although most of those universes would not be nearly as stable as the one we live in. There could be other values that are also being determined by our point of entry, but just how many of the finely tuned constants that create any specific universe and its specific distribution of matter are a result of nothing more than the push and pull between the strength of gravity and the speed of light, and how many of those other constants are not related to those two basic values is a debate better left to the experts. Still, this leads us to an important question. How did we get so lucky as to be on a universe specifically tuned to create life as we know it? String theory is sometimes criticized because it can be used to explain not just the universe we live in, but 10 to the power of 500 other universes as well, each with their own collection of particles and forces. But if all those other possible universes we're imagining really do exist out there in the multiverse, just as real as the one we're living in, then there are no doubt organized collections of information or expressions of matter in some of those other universes that are asking themselves the very same questions. In any particular universe, we can imagine life as being the stuff that becomes interested in what happens next as their universe is moving along its own line of time, being created one quantum frame after another. And that leaves us with a very open definition of life that works well for our own universe, but allows us to imagine a great many other things that could also be called life in those other universes. In September 2007, a team of scientists at Oxford University, under the leadership of physicist David Deutsch, published a proof equating the bush-like branching structure of possible quantum states with the branching choices that each of us within our own physical universe are making as we move through time. This means that whether we realize it or not, at both the quantum level of frames that are one Planck length away from each other, and out here in our physical reality, the actions of chance, choice, and circumstance are moving us down what we think of as a fourth-dimensional line of time. But curled up down at the Planck length, we are actually twisting and turning through the available paths that the Deutsch team have proved really do exist. Imagining that there are parallel universes where each of us make decisions that are different from the ones we make in this one is the outcome of that proof that some physicists are simply not comfortable with. But it's an implication that I've been promoting since I first came up with this way of imagining the dimensions 20 years ago. In my book, Imagining the 10th Dimension, I've suggested a way to blend the concepts of the multiverse, quantum indeterminacy, Kaluza's idea that we're in the fifth dimension, and the M-theory idea that our reality comes from 10 spatial dimensions plus one of time. Mainstream physics tends to keep those ideas separate from each other, so my idea of mashing them up into one big concept is not what you'd be taught in a university physics class. That's why I call my book Imagining the 10th Dimension, subtitle it A New Way of Thinking About Time and Space, and say in promotion for the book that it's not about mainstream physics. What I do say about my new way of thinking, though, is that it is a mind-expanding journey that could change the way you view this incredible universe in which we live. And a great many people around the world seem to agree. The 10th Dimension website, launched in July 2006, continues to grow in popularity, and at the end of 2007 is now averaging 2 million hits a month. Let there be light. It's fun to think about all the possible universes that started from a point in the void, then defined a value for the speed of light, and that's what caused those universes to spring into existence. While it's true that the echoes of those ideas in ancient philosophy and spirituality may be coincidence, I believe this is showing us that human beings have intuitively believed basic truths about the nature of reality long before modern science was able to demonstrate their inner workings. This is why my book deals with so many out-there topics that most scientists are not comfortable with, but the general public are more willing to embrace. This includes ideas about consciousness and spirit, memes and creativity, conspiracies and the end of the world, and so on. Since I'm a composer, not a physicist, I also have 26 songs about the nature of reality attached to this project, most of which are now available as videos on YouTube and Rever.com.